Implementing indexes. Alright, so we're going to learn in this video how to speed up the performance of data retrieval within our databases by using indexes. So let's jump right into it here and get familiar with the outline for this video. We're going to start off with an introduction to indexes. I'll get you familiar with, again, what an index is, why we would use indexes. We'll also take a look at all the different types of indexes available to us in SQL Server. And I also want to go through the architecture of the two major types of indexes because, again, it'll give us a good understanding as to why we would use indexes in the first place. And also here, I'll take you through some very simple, easy-to-use guidelines when using indexes. We'll then get right into the thick of things here and learn how to work with indexes. We'll create all the different types of indexes. We'll set some options on them. We'll learn how to modify and delete them as well. And at the end here, we'll talk about how to maintain and optimize indexes. We'll learn about what's called fragmentation and how to detect fragmentation within our indexes. We'll also learn about how to reorganize and rebuild our indexes. And at the end here, we'll talk about how to optimize indexes by using what's called the Database Engine Tuning Advisor, a really cool brand new tool that'll give us advice on when and where to use indexes. Alright, so let's jump right into an introduction to indexes here, and I want to get you familiar with what an index is and how it'll help us improve the performance of our queries, improve the performance of our database applications, and anything that uses our database overall. Now, what an index does for us technically is it basically just increases query performance, and what that means is all of our select, updates, and deletes, it increases the performance of these dramatically by reducing input-output operations. And really what that means is that it doesn't have to do as much searching for the data on our hard drives and on our disks. So how an index really works here is, let's take a real-life analogy. Let's say that we have a textbook out there, and in this textbook, we don't want to go ahead and read through the whole book, or we're just looking for a specific topic here, a specific subject. Rather than go page by page flipping through this book, we're going to look in the back of the book at the index to find our subject, locate the page, and then flip right to that page to read the data that we're looking for. So that's kind of the gist of how indexes work in the real world using books, textbooks for instance. They work the exact same in relational databases. We create indexes on columns within tables so our queries that use those columns can quickly find that data without having to finger through all of the rows within our table. Now, the reason indexes work so well against select, update, and delete statements is because SQL Server has to find this data before doing any actions against it. So it has to find the data before returning it, find it before it modifies it, or find it before it removes it. Indexes actually hurt the performance of insert operations because what will happen is SQL Server will have to go through a little maintenance routine to fit that new data within the index. So I just wanted to mention that. That's why you don't see the insert statement in here. And we'll talk about this in greater detail as we go throughout the video, and especially when we hit our guidelines area. Another thing here I want to mention is whenever we create an index, we're going to create an index on, of course, one or more columns in the database. These columns are going to be considered the key columns within the index, or the index keys. So if you hear me reference index keys, that's all I mean is the columns that the indexes were built on. And another thing new to SQL Server 2005 is we can create what are called index views. And we're going to get really heavy into that when we talk about and we get into the video about views. And by that point, we'll already know how indexes work underneath the hood, so it'll be a breeze. Now, a couple of other items worth mentioning here is that anytime we designate a column within a table as a primary key, really what SQL Server is doing under the hood is it's creating a unique clustered index. Pretty cool. Another thing here is anytime you create a unique constraint on a column or columns within a table, what it's really doing is creating a unique non-clustered index on that column. So again, just things to take note of. Next time you create a primary key or unique constraint, look at the indexes. You'll be surprised to see that that's all SQL Server is doing is automatically creating these indexes for you on those columns. So let's take a look at the different index types available to us. And the two big major index types we have here are the clustered index and the non-clustered index. And I'm going to give you an analogy on both of these to kind of get you to understand how different these are from one another. Let's go back to our textbook analogy, for instance. A non-clustered index is just that. It's a textbook where the index is stored in the back of the book, separate from the actual data. If we want to find the data, we have to go to the index, find what page the data is on, and then go and flip to that page. So really the index just serves as a pointing mechanism to the actual data, right? Now a clustered index is more like a telephone directory or a phone book. Because what will happen with a clustered index is it's stored with the index. So for instance, if we're searching a phone book and we find the last name of an individual and then we search by first name, we find that individual, we don't have to look any further. The data is right there with the individual, that being, of course, their phone number in a phone directory. And that's the difference between a clustered index and a non-clustered index, is really how the data is stored underneath the hood. and also how that data is accessed. Now, all indexes, no matter what type of index you build, they all take the shape of what's called a B tree, which is an on-disk structure inside of SQL Server that'll actually be the index itself. And a B tree stands for binary tree. So that's what a B tree is. And what it looks like is kind of like this over here. It's an upside-down tree where you have a root node, then underneath the root node here, we have intermediate nodes or intermediary nodes, and then underneath the intermediary nodes, we have what are called the leaf nodes. So this is really what a B tree is and what indexes look like underneath the hood. And you can see just by looking at the structure, of course, this tree would get massive depending on how much data is in your table. But it would be a lot easier for SQL Server to navigate and traverse this tree and find specific data, because this is how it works. Take a look at a clustered index here. Here's, again, in its simplest form, this is how it would work. If we were searching for, we wrote a query to search for the name Andy, and if, say, of course, our index key is put on a name column. Well, if we were to look for Andy, SQL Server would come into the root node here. It would say, all right, where's Andy at in this mess? And SQL Server would do a text comparison to see that AN is less than AM, so it would automatically know to go over here to the A's, right? The next thing it would say is it would look for Andy. Again, text comparison. It would find that this is an Andy row, and then it would say, all right, this is on page 1, row 3, in which case it would just go traverse down here to the leaf node to find row 3 and extract that row and, of course, any data associated with it and return it back to the user. And again, in its simplest form, this is how indexes work. And look at that. It just searched one side of the tree, traversed the nodes to find the specific data. It didn't have to scan through the entire table as it would without an index. Now, what you're seeing here is an actual clustered index, and that is because, just like our phone book analogy here, once we find the name we're looking for here, once we find Andy, the rest of that data is stored with it. And that is because the leaf level of a clustered index contains the actual data pages themselves with all the data on it. So it doesn't have to look much further once it hits this leaf level and finds the data. Another thing worth mentioning here is the clustered index. The data is sorted and stored based on the index key. So you can choose a sort order when you create the clustered index, but by default it's going to be ascending here. And this is exactly what a clustered index on a name column would look like, sorted by name. Now a non-clustered index is going to work a little bit differently here because, again, a non-clustered index just stores pointers to the actual data. So what we would have here, and a non-clustered index actually works differently depending on if there's a clustered index already on the table. Let's say there isn't. If there isn't a clustered index already on a table, what will happen here is we'll have another row in here, and or another level, I should say. And the leaf level is, again, they're just pointers to the actual data pages. So we'd have another level here with the data pages down below. So the leaf level would be another intermediate level, really, for all intents and purposes. And it would just use this leaf level to look at the pointers and then find the actual row locators, the row IDs inside of these data pages to extract the rows. Now let's say that there already is a clustered index on this table. What will happen then is these pointers will not be pointers to the data pages, but they'll be pointers to the leaf level of the clustered index. And that's the difference here, and that's how that works. So these are the two main types of indexes in SQL Server. Again, the clustered index, you can only have one per table. It's a very high performance index, and there's really very few scenarios where you wouldn't want a clustered index on your table. And we also have non-clustered indexes, which are, again, another type of index that we would use to speed up and enhance query performance. And we can have pretty much as many as we want of these on a table. There is a limit, but the limit is very, very high. Other index types we have down here are the unique index. And a unique index is great for when we want to create and enforce uniqueness on a specific column, because it will guarantee that all the data that goes into that column or any keys inside of this index are unique, so column or columns. And that will also, of course, then guarantee that your record within the table is also unique. And one thing I want to mention here, clustered and non-clustered indexes can both be unique or non-unique. We also have included indexes, brand new to SQL Server 2005, and an included index is really cool. What this allows us to do is create what's called a covered query, or a covering query, as you may hear it out there. And what that really means is, and this is really just an extension of a non-clustered index, because what it'll allow us to do is add what are called non-key columns inside of our clustered index. So when we create any form of an index, we actually designate those key columns, right? They're stored in the actual index pages themselves. If we include these non-key columns inside of a non-clustered index, what it'll do is it'll take those columns and it'll store them in the leaf level of the index pages. And what that'll really, what that boils down to here is that we can take a query and all the columns that are referenced in that query, and the where clause and the joins, group by, order by, and in the query itself, and we can throw them inside of an index and cover it so that every single column in our query is covered in our index. And what will that do? Well, that'll mean that the index won't have to go to the data pages to grab the data. It'll have everything in the index, resulting in a very, very high performance query. So when we get into our demo here, I'll show you how to create non-clustered indexes with included columns. And really, they just give us another option here when dealing with poor performing queries, so we can speed them up. We also have full text indexes. Full text indexes are more of an advanced topic that we'll save for a future video, but I did want to mention it here because it is a type of index. And just briefly here, what you can do with a full text index is put it on a column or columns, and you can do sophisticated character searches on top of character and text data. We also have XML indexes, another more of an advanced feature that we'll briefly touch on when we get into our XML video. But basically what this is just an index on top of an XML data type column. All right, let's head on into some indexing guidelines here before we jump into our demos and get familiar with how to create indexes. Now, the first thing I want to mention here before we get into our guidelines is there's something inside a SQL Server called the Query Optimizer. And the Query Optimizer is this very intuitive little component that sits inside of the database engine that intercepts all the queries coming into SQL Server. And what it does is it looks at the queries coming into SQL Server, and it makes decisions. It evaluates all of its options to find the most efficient way to return the data back to the user. And here's how it works. It's going to evaluate, and it's going to do one of two things. It's either going to do a table scan on the data, or it's going to search indexes on the table if there is an index. Now, it may use a table scan even if there is indexes on the table if the query is going to return a high percentage of rows in the results, right? Because it'll be faster than using an index to return those rows in the first place. Otherwise, it's going to use an index. And if you have multiple indexes on this table, then the query optimizer is going to evaluate all of those indexes to determine which one is the best to use and the fastest to use in order to return this data back to us. So what this boils down to is that it's our job to give the query optimizer as many options as possible by designing effective and efficient queries. Now, a few other things that I want to mention here is we're not totally in the dark. We have some pretty cool tools inside of SQL Server that will allow us to see exactly what the query optimizer is doing. The query optimizer actually generates what are called execution plans and then passes them into the database engine to use those execution plans to, of course, get the data. So we can actually view these execution plans within the SQL Server Management Studio to see exactly what indexes the optimizer is using. So we can tell, which indexes we'll need to tweak, which ones are performing well, so on and so forth. And there are other tools too. We're going to actually take a big look at the Database Engine Tuning Advisor to get, again, more advice on what tables we should index and what columns in those tables we should index as well. All right, let's move into some indexing guidelines here. Non-clustered and clustered indexes. The main differences between the two, other than, of course, the architecture and how they work, is how they perform. Non-clustered indexes we want to use on what are called exact matching queries. So queries that are going to return exact matches. In other words, in our where clause where we do a where column equals value, right? Because of this, of course, they work on queries that do not return large data sets. So exact matches are great for non-clustered indexes. Clustered indexes are the exact opposite. We want clustered indexes that work on a range of data. Again, because it's a high-performing index here, it can handle ranges of data. And just the way the architecture is and the way that SQL Server navigates clustered indexes, it's very efficient to work on ranges of data. And of course, therefore, queries that return large data sets. So this would be where you use the between operator, your greater than, less than operators to search all forms of data, date ranges, character ranges, numeric ranges, so on and so forth. Non-clustered indexes, again, great for covered queries. If you want to cover the query, in other words, you want to have all of your columns referenced in an index, the non-clustered index will perform and shine best because it won't have to go into the data pages. It can just use the index in the leaf level pages to grab all of those columns that are covered inside of our index. We also, both indexes are great on columns that have a high degree of uniqueness. Also here, foreign key columns. Foreign key columns that are one-to-manys here, the one-to-many sign, are great on clustered indexes. Foreign key columns are great on non-clustered indexes that are one-to-one. Again, this just goes back to that whole range versus exact matching thing. And then non-clustered and clustered indexes both great on anything with the group by in them, and then clustered are good anything with an order by in them, and that's, of course, comes down to the architecture because clustered indexes are stored in sorted order underneath the hood. So, of course, it's only logical that it'll be a lot faster for clustered indexes to search when you have an order by in it. Some other general database guidelines here. Avoid over-indexing heavily updated tables. This goes back to what I was mentioning earlier about inserts. Again, anytime you have a lot of indexes on a table, even one index on a table, and you insert a row, what it'll do is SQL Server will have to make room for that row in the index. And if there's no room on a certain index page or a leaf level page, it'll have to go through what's called a page splitting process. It'll have to split the page up, move some rows to one page, leave half the rows on another page, and then put those pages in order within the index. So it's a pretty hefty maintenance process that has to occur every time you add data into the table. Now imagine if you have multiple indexes, 4, 5, 6, 10, 20 indexes. Well, yeah, it's only going to get worse. So avoid over-indexing heavily updated tables. And on the flip side of that, over-index the heck out of tables that don't have much data modification. So not many inserts, not many updates. Go ahead and index the heck out of them, because it really doesn't matter, because that'll actually give the query optimizer many, many, many choices when it comes to running queries on them. And then again, avoid indexing small tables, because SQL Server is going to end up doing a table scan anyway. So and of course, small static tables especially, because again, SQL Server is just going to do a table scan to grab that data anyway. All right, let's head on in and learn how to create indexes. So what we're going to do here is fire up SQL Server 2005 by going to Start, dragging up the programs on over to SQL Server 2005, and right down to our SQL Server Management Studio here. As soon as this fires up, we're going to connect to our SQL 2005 prod instance over there on our SQL Nugget machine. I'm also going to open up a query here, or a script I should say, or implementing indexes script, and we're also going to connect this up to our 2005 prod database. I'm going to hook us right into the CBT Nuggets database. Now we'll come to, and I'll show you how to do all this via script here shortly. First, what I want to do is show you how to create all these different types of indexes using the interface. So if we head on into the databases node and down to our CBT Nuggets database, in here we have our series, trainers, and videos table. The first thing we're going to take a look at here is how to create a clustered index. And the easiest way to create a clustered index, and of course I'll show you the kind of the old way we used to do it in SQL Server 2000 and previous, is we go into our table, we'd right-click on it, we would choose Modify it to modify our table, kind of really just going into the properties of the table. And the easiest way to create a clustered index is, of course, to create a primary key. So you choose your column, you click Primary Key, boom. Underneath the hood, as I mentioned earlier, it actually created a clustered index for us. And you can see this by clicking right here on Manage Indexes and Keys. If you click on this button, this will show us all the indexes associated with this table. And check it out, it automatically created for us this PK underscore videos, which is of course our primary key, but really what it is a clustered index. You can see here, create as clustered, yes. And of course, again, the name of the column here, followed by the sort order of the data inside of our index. It's also unique by default. The type here is primary key, of course. The name here, the description. You can do a couple of other things as well. Again, create as clustered, yes. What file groups it's stored on, and then the fill factor, which I'll talk about here briefly when we get into our other indexes. But that's all there is to it. To create a clustered index using the old way, very simple. You can do it as a primary key. And now if we save our table here, click on the Save button, we'll close out of it. Now we can come on down into indexes, and look at that. There it is. And you can view the index by double-clicking on this here. And here's the actual, we're going to get really familiar with this screen here, because this is kind of the new way to create indexes. And this is how we'll create our non-clustered, unique, and our covered indexes by using this interface. So that's one way of creating a clustered index. And again, you don't actually have to have your primary key as a clustered index. You could very well make a non-clustered index and make it unique and set that as a primary key. And maybe you have a column somewhere in the middle of your table that is frequently searched on as ranges. It may be a better candidate for a clustered index. But 9 times out of 10, there's a reason that Microsoft automatically defaults your primary keys to be a clustered index, because 9 times out of 10, it's the best decision. Now, other things here. Our trainers and our series tables both already have clustered index as their primary keys, so I just want to point that out here. The next thing I'm going to show you how to do, though, is create a non-clustered index. And what we're going to do here is create a non-clustered index on the trainers table, and it's going to be a composite key index. In other words, we're going to have more than one column in this index, and this would be a good candidate if individuals in our company were searching, using an application to search for trainers within our database. More than likely, we're going to have queries out there that are going to use the first and last name of the trainer to find videos or find series or anything associated with the trainer. So it would be logical to put a non-clustered index on the first and last name of this table. So here's how we would do that. Let's head on over to our trainers table, head on down to the indexes node, right-click on it, and choose New Index. We'll get a familiar-looking dialog box here where the first thing it's going to have us do is enter the name of the index. So let's call this IX underscore trainer's name. The next thing is, of course, our index type. We're going to make this a non-clustered index. We're not going to choose unique, simply because you never know. We may have trainers with the identical first and last names here, so we wouldn't want to do that. The next thing we do is choose what columns are going to be involved in this index. What are our key columns going to be here? So if we choose add, we're going to choose first name and last name and choose OK. And there we go. And you can also here you can change the sort order of this of the index itself, how it's sorted in the index pages, and other things in here too, just general properties, the data type, the size, and what type of column it is. So once you get to this point, you can either choose OK and it'll create the index, or we have some options here. I'll go through a few of these. Microsoft actually recommends that most of these are left at the default setting because there are very, very, very few scenarios where they'll actually help us out. Ignore duplicate values isn't one of those, simply because this is for if you create a unique index but you want to ignore all the current data in there, then you can click on this. We're going to leave that empty. These are the ones that Microsoft really recommends leaving alone. Automatically recompute statistics all the way down to set fill factor. And really this is an important one. Set fill factor, it's good to know. Basically what you can do here is this has to do with that whole page splitting thing. If we choose a fill factor of say 50%, what this will do is when it creates the index, it'll automatically all the leaf level nodes, all those data pages in the leaf level nodes, and all the index pages in the leaf level nodes will actually only be filled up 50%. So they'll leave plenty of space on all of our index pages at the leaf level for more data. So more data can fit on them and less page splitting will occur. Now again, Microsoft recommends that we leave this at either 0 or 100%, which is the exact same thing. 100% and 0% means it'll fill the pages as full as possible, and it'll only leave enough room for one or two index rows to happen. Pad index actually does the same thing. It'll take this percentage, if it's anything other than 100 here, and it'll apply it to the intermediate nodes. So the fill factor works on the leaf level nodes, the pad index works on the intermediate nodes, and it's just a setting that determines how full those pages will be when created. So we're going to leave this again here. Let's just leave that empty, which will put it at 0 or 100%, which is the same thing. Another really cool feature, brand new to SQL Server 2005, is we can have what are called online indexes. In other words, anytime we create our indexes, in the past it was an offline operation. It had to take the table and the data offline to build the index. Now, new in SQL Server 2005, and only with Enterprise Edition, mind you, we can do online processing of DML statements while creating an index, and also while rebuilding our indexes, which we'll get into here shortly. So a very, very cool new feature here. It will take a little more time to create the index because it is going to be online and allow users to still access this data while creating it, but very useful feature, especially for databases that need to be up 24/7. And of course, at the end here, we can choose Use Index if you want to disable the index or enable the index. And of course, we're going to choose Enable here by default. Other things, included columns. Again, we'll get into this when we talk about our included column index. And then storage, you can just choose what file group this index is stored on. So everything looks good here. Let's go ahead and click OK. And it's going to create the index for us. And there it is, IX_trainer's name, non-unique, non-clustered index on the first and last name in our trainers table. Now the next index we're going to create here is we're going to create a unique index. So this unique index we're going to create on our series table, and we're going to put it on the series name and price. We're going to say that no series name and price together can be duplicated. They have to be unique within our table. So let's head on into our series table here, head on into our indexes, right-click on it, and choose New Index. So this one we're going to go ahead and let's call this IX_series name, series name price. This will be non-cluster, but this time we're going to choose unique, and then we'll add our columns in here. We're going to say series name and price. Click OK. Click OK. As easy as that. Now, anytime data is entered in this table, it has to be unique between the series name and the price. So simple as that. All right, the next thing we're going to do here is create a covered index. So to do this, we're going to head on down to our videos table. And what I want to do here, let's say that we have a search engine on top of our videos table where users can come in and search for any video they want using any of the columns in here. Well, it would only make sense that we would want a very high-performing query to do this. And what we can do is create a covered index, an index that takes all of these columns in it. So again, when users are searching and throwing queries at this table, it won't have to go into the data pages to find the data because they'll be covered. We'll have all these non-key columns covered inside of the leaf level pages of our index, and then we'll have one key column here as well. So to do this, very simple. We again head on down to the indexes, right-click on it, choose New Index. We're going to call this one IX_covered videos. We're going to make our everything pretty much the same here, non-clustered, not unique. The first thing we do is add a key column. So the key column that we're going to add here is our series ID. So a great candidate as a key column because it is an integer, and again, numbers very, very fast when stored in the index pages. So we'll leave that as our key column. If we head on down to our included columns node here, it's just like adding any other columns in here. We just click the add button, and then we're going to choose all the rest of these. And we already, again, remember, we already have a clustered index on our video ID, so we don't have to worry about that. And now look at this. We have not only covered any query that accesses this table is covered, but our whole table is covered because we have an index for pretty much every situation. So now if we choose OK, check it out. There it is, our IX covered videos. So now any queries that access this table, especially use any of those columns in it, especially if we have a query that takes all of those columns into consideration, it's going to be a very, very high performance query. So very simple to make these indexes, and really including them is just adding non-key columns into your index. Now dropping indexes, piece of cake. You just do drop index followed by the name of the index. So if we wanted to drop our series name and price index here, we could just highlight the code, click execute, boom, as easy as that. And you can also, of course, just come in here and right-click and choose delete as well, just as easy. So let's go ahead and recreate that index to show you that it is gone here. Refresh, no longer there. Let's highlight our code there to recreate it, and boom, we're back to normal. So we got our index back, no problem. Now another thing I want to talk about here is maintaining our indexes, maintaining, rebuilding, and reorganizing our indexes. Now why do we need to maintain our indexes? Well, indexes become fragmented over time, especially on tables that are inserted, updated, and deleted on even a little bit. Because what happens is SQL Server is constantly reorganizing our indexes around. Things are going to get scattered. Data is going to get scattered just the way it is. Happens on hard drives, happens on indexes. So what we need to do is be prepared. And there's a few really cool things in SQL Server 2005 that'll help us detect fragmentation. And also really what you'll need to do, and the smart thing to do, is create a maintenance plan. Create a database maintenance plan that rebuilds your indexes, reorganizes your indexes at automated intervals throughout the week or throughout the night on heavily updated tables. It'll really save you the hassle of doing this. But the really nice thing about SQL Server 2005 is once you go back into this index, let's check it out. Let's go into our index we just recreated here. If you double click on it, we get a brand new node on here called fragmentation. And this is really nice because it gives us a lot of good information relating to how fragmented our indexes are. And you can also see how full your index pages are, 4.65%. Total fragmentation. This is really the key number here that you're going to look at. And if you click the help button up here, you can actually get really detailed information for what each one of these properties means. But again, the important one here, total fragmentation. A general rule of thumb is if you're less than 30%, you'll want to reorganize the index. If you're greater than 30%, you're going to want to rebuild the index. What's the difference between the two? Reorganizing, it actually, SQL Server will just go through and reshuffle and reorganize all of your index pages to be in the correct order. Rebuilding, however, actually drops and recreates the index itself, and a little more timely, a little more resource intensive of a task. But again, if you're greater than 30%, then you're going to want to rebuild the index. But because we can do all of these online now, it really doesn't matter. So how do we go about rebuilding these indexes? Well, very simple. You can right-click on an index. Look at this. Rebuild or reorganize. Very, very simple. Reorganize, again, is just going to go ahead and it's going to actually just try to reorganize these pages together without deleting the index. So if you click OK here, boom, see how fast it was? Of course, it's very fast because there wasn't anything to reorganize. And of course, rebuild then will actually go ahead and it will drop and recreate the index. Again, that's very fast too because there's not a lot of data in here and our index is brand new. But general rule of thumb, very simple to follow. Less than 30%, reorganize. Greater than 30%, rebuild. But you're better off just getting a maintenance plan down and putting it on a nightly or a weekly schedule to rebuild your important indexes. Now, one more thing I want to do here is I want to take you through what's called the Database Engine Tuning Advisor. And the Database Engine Tuning Advisor is a very cool, brand new tool incorporated into SQL Server 2005 to give us advice on where we should use indexes within our database. Now, this is actually, it could have an entire video dedicated to it just because there's so much that can happen within the Engine Tuning Advisor and a lot that you have to do. So what I'm going to do is I'm going to run through a demo and try to show as much as I can about the Tuning Advisor. But really, you're going to gain most of this by watching a demo just to see how it works. And then you can test it out and play with it on your own. And it'll really, it's a very, very slick tool, very easy to use. Now, before I do that here, I built a little query. And this query here takes a first name and last name of a trainer and grabs all the series and all the videos associated with that trainer. What I wanted to show you here before we jump into the tuning advisor, remember I talked about those execution plans display, you can kind of see what's happening, what index the query optimizer is choosing when running your queries. Well, I'm going to go ahead and I'm going to highlight this query here. And if you go up here, you can see display estimated execution plan, and then we also have over here include actual execution plan. So if you click on this, what will happen is it's actually just going to go ahead and it's going to say, all right, this is what I would do if I were to run this query. This is how I would run it. And this is what an execution plan looks like. It just goes through and it shows exactly what it would do to gather that data. And you can see here what it's going to do is it's going to use the clustered index to grab this data. And it also, you can see it's also going to use the regular index on first name and last name. So it's going to use the clustered index and the regular index to grab this data, which is good. That's exactly what we want. This would be a very, very high performance query in any given situation. So you can really use this tool here to see what indexes your query would use. So just another way to analyze what's going on with the query optimizer. Now, if you wanted to see the actual execution plan, you can click on this button right here and push it in, and what will happen now, anytime you hit execute, if we want to search for all of Dan's videos here, we hit execute, check it out. Now it actually just includes a tab here with the actual execution plan, which is, of course, the same as the estimated one in this case. So pretty cool stuff there. So onto the database engine tuning advisor. Now what we can do with this, again, very slick tool, we can have it analyze just a specific query here. If we have a slow performing query or a query we want advice on where and how to index, or we can actually say we want to analyze an entire workload. So what you would do at the workload level is you'd set up SQL Server Profiler to trap, from point A to point B. Say your application, you don't know where in your application, but you know you have a bottleneck somewhere in your application. Well, you can trap anything that happens within the application in a SQL Server profiling session, save the trace file as a workload, and then load the workload up into the Database Engine Tuning Advisor, and it'll analyze everything in that workload and give us recommendations on what to do. So a very cool tool here. Let's just do it at the query level here just to kind of give you an idea on how this works. So we'll highlight a query here. We'll come up and choose Analyze Query in Database Engine Tuning Advisor. And what this is going to do, it's going to fire it open. It's going to automatically create a session for us. And all we need to do, really, is give our session a name. So let's call this the video query. And then it automatically chose query for us, what database we're working in. We want to choose all the tables in our database. You have some options in here to choose from. A PDS, a physical design structure, is just simply what you're doing. Of course, indexes are physical design structures within the database. You can limit the time it takes. There's some advanced options in here. We're just going to go ahead and choose a max space of 6 megabytes here, so it doesn't go above that. And that's pretty much all you have to do. So set some options, choose what database, what tables you're running on, if you want to save the log or not, and then you can just simply choose Start Analysis. So this will actually run through, it's analyzing our query right now, analyzing all the tables that our query is hitting, and then it's going to come up with a recommendation on what we should do with this query. Now, since we already have indexes on this table, it should come back and say, you're good to go. So if you look at this here, you can notice there's no recommendations at all. So here's all the tables that it's hitting, the series, the trainers, and the videos table. And guess what? We already looks like we're at optimal here because we already have our primary key. It's used a primary key. It uses our index that we created, the series name and price, our trainers index. It's basically going to use all the indexes here. So we're at optimal performance already, and it just shows us the details, what type of indexes are already on here. But the point here is there are no recommendations. If you go to the reports section here, you can see there's plenty of reports in here. The statement cost, percent improved, none. We're at optimal performance here. There's a detailed report on how long it actually took to get the data. And very, very good stuff here. Index usage reports, what indexes it actually used. The covered used all of them. All the indexes that were touched in our query, it used. Percent usage here, number of references, things like that. So again, very, very detailed tool, very easy tool to use. It's just getting familiar with what all this data means and all these property means. But the point here is we don't have any recommendations because we're at optimal. We have all of our indexes covered on all of our tables, and this query is performing just fine. So pretty cool stuff here that you can use this Database Engine Tuning Advisor to get advice on not only queries, but just to show you here, if we come in here, we right-click and choose New Session, look at this. You can also, here's a workload. So a workload can come in the form of a file or a table. That just depends on what you do when you start up SQL Server Profiler. And just to run this through really quick here, we'll set up a quick trace on our prod machine. We'll just leave this at untitled here. We'll leave all the defaults. Now that we run it, if we go back to SQL Server here and we execute our query, that should have been trapped right here. Now we're just going to go ahead and stop our trace here. Let's go ahead and save it. Save it as a trace file. Why don't we give this, put it on our desktop. We'll call this videos. Hit save. Now, if we head back into the Database Engine Tuning Advisor, load up our file that's on the desktop, we can do pretty much the same thing from here. Choose our database, choose our tables, set our options up here. Name this for 6. Click OK. Start analysis. And it's going to do the same exact thing that it did here. But the point here is that you can set up SQL Server Profiler to trap not just one query, but an entire process within an application, especially if you have a bottleneck. And then it'll analyze everything, all the queries within there, and give you recommendations based on pretty much everything. You can see here it didn't just analyze our one query, but it analyzed virtually everything in here. Same thing then. Just gives you recommendations or no recommendations if you're already optimal. So I advise getting familiar with the Database Engine Tuning Advisor. It'll just take a little bit to get familiar with everything there is, all the data that is trapped in here. But overall, an excellent tool, a great troubleshooting tool that will help us make smarter decisions when we're creating our indexes. Alright, so in the CBT Nugget, we took a big look at indexes. We started off here with an overview of indexes. I took you through what an index is, the different types of indexes, the two major indexes there, clustered and non-clustered indexes. We took a look at the architecture of clustered and non-clustered indexes and saw that clustered indexes are like a phone book where the data is stored with the index, and non-clustered index is more like a textbook where the data and the index are separate. We then took a look at just guidelines to follow. We took a look at guidelines for non-clustered, for clustered, some general database guidelines, and then I took you through a big demo on everything indexes. We started off here with clustered indexes. We moved into non-clustered indexes, unique indexes. We took a look at covered indexes, and really all the different forms of indexes available to us we pretty much looked at. The only really ones we didn't look at are the two advanced ones, full text and XML, which we will touch on in later videos, and also index views, which we'll touch again on later videos. We then took a big look here at maintaining and optimizing indexes. I give you a brief look at how to detect fragmentation. Very simple now in this version of SQL Server. Also how to reorganize and rebuild indexes and what the difference between the two are. And at the end here, I took you through a very quick but very detailed demo of the Database Engine Tuning Advisor and saw the multiple ways we can use it to enhance the performance of our queries and also get advice on where we can utilize indexes within our databases. So I hope this has been informative for you, and I thank you for viewing.